Hello officials, I am Ms. Sneha Banala, currently pursuing Masters in the University of Georgia, Athens, and a graduate student from Vienna Jyoti Institute of Engineering and Technology, India, in the Department of Computer Science and Engineering, affiliated with AI and ML. The topic I am presenting on is leveraging image fusion and transfer learning for enhanced tumor diagnosis. The abstract. Brain tumor diagnosis has become critical in most of the conditions, so there is a need for the development of efficient and advanced diagnostic approaches. Doctors mostly use MRI and CT scans. They are very reliable and well established powerful diagnostic tools. This paper aims to demonstrate that fusion of MRI and CT scan yields better results than MRI or CT scan alone. Fused scan has a potential to highlight subtle details that may be overlooked on individual scans. Coming to the introduction, MRI surpasses CT in visualizing soft tissues and hence boosting accuracy. MRI gives a picture of extremely soft and smooth tissues, but CT highlights clear-cut bone details. Sometimes diagnosis using MRI is difficult when tumor is small or at initial stages, as the location detection of the tumor becomes a hard task. To overcome the above research gaps, this study investigates the MRI and CT fusion merging for the strengths of modalities and generating a more comprehensive image of brain scan that can surpass both the individual scans. The proposed model contains the following stages. The first stage has collection of brain tumor, MRI and CT scans from the Kaggle. And the second stage will generate a fused images dataset for training the brain tumor detection model. And then we'll classify the brain tumors into four types of tumors. Those are specifically glioma, meningioma, pituitary, and no tumor. So, the generation of fused images is done using VGG19, and this has some stages. And the first stage is landmark-based registration. This registration is done with minimum of 5 and maximum of 10 registration points. After this registration, the two images, that is, the CT and MRI images, will be aligned in the common coordinate space. The points, that is minimum of 5 to 10, are selected manually by the user. And then the transfer learning and discrete wavelet transform for fusing the images. Both the images are are placed and aligned properly in the common coordinate system. And then the image segmentation. In the image segmentation, the different portions of the image are separated. This is the overall structure of the proposed model. The brain tumor detection and classification. As it is a multi-class classification, will perform label encoding to classify into classes. Feature extraction is performed and train the same CNN model once with a fused set of images and once with the MRI set of images to perform the analysis. So here, the fused images dataset and MRI images dataset are trained twice, and then pre-processing is done using label encoding and the image segmentation, and then feature extraction, and the multi-class classification using CNN, which will classify the types of tumors into glioma tumor, meningioma tumor, pituitary tumor, no tumor. And the results of the evaluation metrics are gained, and these metrics are used to analyze and compare which of the datasets is giving more accuracy. So this is the CNN layers we have laid on. We have used the sequential model and 9 convoluted layers, 4 max pooling layers, dropout layers 6, and 3 dense layers and 1 flattened layer, overall 23 layers. And we have used ReLU and softmax activation functions. And the loss function we have used is categorical cross entropy. And we have used ADAM optimizer. And the metrics we have taken are accuracy. The input image size is 150 into 150 into 3. So we have designed the web app for this, and the first page will ask you to upload the MRI image, CT image, and ask you to select how many manual points you're going to select for registration of image. And then it will redirect to this first page, that is select coordinates of for registration process. Here we are supposed to manually select the registered points on the MRI and CT both. Make sure the MRI and CT images are of the same person. And then you can submit the data, and hence it generates the fused image. This is a fused image of the both MRI and CT, which will have all the information of MRI and CT both. Results and discussion. Now, a fused image's quality is assessed by three criterion measures. First one is mean square error. It has to be always low in order to get more accuracy. And peak signal to noise ratio. It should be at least moderate for overall fidelity. And structural similarity index, it must be definitely high in order to preserve structural information from both the images. So the metric values we have gained after fusion are: the structural similarity index turns out to be 0.91, peak signal to noise ratio turns out to be 21.09, and the mean squared error is 506.32. Overall, it tells that fusion has been done in better way. And coming to the classification, the model tested using fused images resulted in 94.63 accuracy, and model trained using MRI resulted in 92.98 accuracy. The reason for high accuracy of the fused images is that the fused images contain all the important information from CT as well as MRI. This results in peaking model correctness. So this is the bar chart we have got after training and testing with both fused and without fused images. And hence you can see here that with fusion, the accuracy of training and the accuracy of testing is greater than without fusion accuracy of training and testing. So the conclusion is the proposed methodology significantly reduced the value of PSNR and achieved improved accuracy, that is 94.63% when compared to the state-of-art methods. The current study proposes the hybrid fusion-based brain tumor classification application using deep learning and data analysis in detecting brain tumors. Fused images offer a more complete view of the brain by combining the precise bone structure data from the CT scans with the detailed soft tissues information from the MRI scans. Hence, the fused images contain both the information from MRI as well as CT, hence giving us more data in order to classify the brain tumors. Using this information, the model can classify tumors more accurately than using them individually alone, which may result in earlier diagnosis and better patient outcomes, and also overcome the research gaps which were in MRI or in CT. Thank you.